Hey everyone, welcome back to Think Tech. And in today's podcast, we'll discuss about a very important concept in software development, that is the SOLID principles of object-oriented programming. SOLID is an acronym that stands for 5 design principles that help software developers to create maintainable, flexible, and scalable software applications. These principles were introduced by Robert C. Martin, otherwise famously known as Uncle Bob, in the early 2000s and have become a cornerstone of software design since then. Robert Martin was the same person who also co-authored the Agile Manifesto, so he's a very famous name in the software world. And these principles were also given by him to allow developers to write better quality code. So let's dive right into each of these principles and understand what they stand for. So the first principle, that is the S in the SOLID acronym, is the single responsibility principle. The single responsibility principle, or SRP for short, states that a class or a module should have only one reason to change, which means it should have only one responsibility, which basically means that a class should do only and only one thing, and it should do that one thing very well. The motivation behind the SRP principle is to promote the development of a code that is easier to understand, modify, as well as maintain. When a class has multiple responsibilities, it becomes harder to change any particular functionality of the class, as any change that is made in that class or any one responsibility of that class can have unintended consequences on the other responsibilities. This is something that we commonly face in a legacy code where we change something at one place and something at the other place breaks. So this is because these principles were not followed while writing that code. So that is why single responsibility principle is an important coding principle that we should keep in mind, as not following this principle can result in a code base that is very difficult to maintain, debug, and extend. To adhere to SRP, a developer should identify the responsibilities of each class, ensure that they are narrowly focused. This means that the class should be responsible for only one aspect of the system behavior. So as we discussed, only one responsibility per class. For example, if you're writing an authentication class, so if it handles user authentication, it should not be responsible for something else, like maybe notifying for authentication failures or handling something completely different, like handling payments and all those things. So it should not be responsible for more than one thing. By following SRP, a developer can create code that is more modular, testable, as well as easy to extend, since each class can be developed and tested independently, which makes it easier to identify and fix any potential bugs. Additionally, the code base becomes very flexible, so adding new features also is very easy if the single responsibility principle is followed. So in summary, the SRP principle is a very powerful tool for developers, and by adhering to this principle, developers can create code that is very easy to understand and extend. So moving on to the next principle, which is the open and close principle. The open close principle, OCP, states that software entities like classes, modules, functions should be open for extension but closed for modification, which basically means the behavior of a system can be extended by adding new code rather than changing existing code. So we should in all circumstances avoid changing any existing code to add a new behavior. New behavior should only be allowed if it results in adding new code, or that is how the code should be written, that adding new behavior results in adding new code. The motivation behind OCP was to promote the development of code that is again flexible, maintainable, and scalable. When a system is closed for modification, it is very easy to maintain, as you don't have to change existing code for anything that you add. And because we don't have to change anything in the existing code, it reduces the risk of introducing bugs and any unintended consequences whenever a new feature is added to our code base. To follow OCP, a developer should design the system with extension points in mind. that will allow new features to be added without modifying the existing code in future. And this can be very easily achieved through the use of abstract classes, interfaces. I'm talking with respect to Java. So in Java, we can easily achieve this by using abstract classes and interfaces. And in other languages, we can use other design patterns that provide the same level of indirection between the existing code and the new code. And as we discussed, by following OCP, a developer can create a code that is modular, testable, extensible. Each component of the system can be developed and tested independently, which makes it easier to identify and fix bugs. Although you will have to put a lot of thought while designing your application, but that makes the code base very flexible. So adding new features for future developers is very easy. So this is a very good principle to follow, because this means maintainability of the code very easy. The next principle in the S.O.L.I.D principle list is the Liskov Substitution Principle. So this again is a very important principle which states that the objects of a superclass should be replaced or should be able to be replaced with the objects of its subclasses, and doing so should not cause any error or any unexpected behavior. So in other words, a subclass should be able to substitute for its superclass without breaking the behavior of the system. So the main motivation behind LSP was to promote the development of the code that is predictable. When a subclass can be used in place of its superclass, it makes the code easier to maintain and test, and also allows for greater flexibility in the design of the system, as new subclasses can be added without affecting the existing code. Now, to adhere to LSP, a developer should ensure that the subclasses obey the contracts established by their superclass. That is very important. This means that methods and properties of the subclass should behave in the same way as the superclass. You should not have any additional behavior or any additive properties in the implementation of the methods in the subclass. So let us think in this way, that whenever we extend methods from superclass, what the expectation is that the missing implementation of that method will be added in the subclass. But if we use those functions to perform something that is completely different from the intended use of that function, then we will not be able to replace that superclass with the new subclass. So this is something that we should avoid in our code, because that makes the code very brittle and also very difficult to test, because then we are not staying true to the blueprint of how we have designed our application. We have added code that does not belong to that particular function. So by following this principle, as we discussed, that a developer can create a code which is more testable and again very modular, and the code becomes more flexible. So just to add before we move on to the next principle, Robert is a very strong proponent of TDD, which is test driven development. And that is why we see that in all these principles, the basic idea or the basic core principle behind all these suggestions is that the code should be independently testable. So the TDD development paradigm states that you should write tests before you write any line of code. So to adhere to that, you need to make sure that you are writing code which is independently unit testable. So that is the underlying principle behind, or that is, I think, the correct frame of mind with which we should understand these principles, because these principles are very stringent requirements. They are very strict requirements and very difficult to follow if we do not understand the bigger picture of why actually we are trying to do this. Because you can write code in 1,000 ways, but there are certain ways which have been time tested and proven to perform very well. So I think this is the end result of all those years of experience that he has had in the industry, and that is why on the face of it they might not look very helpful but more work, but in the end, whatever is the end product by following these principles is a very neat and clean, good quality code. Okay, so get back to the principles. So the next principle that was suggested is the Interface Segregation Principle. The Interface Segregation Principle states that clients should not be forced to depend on interfaces that they do not use. So again, this is a very important point. A class should only be required to implement the methods that it actually needs, rather than being forced to implement a large interface that has n number of methods, half of which the class is not going to ever use. And again, the motivation behind ISP is the same: to write code that is easy to maintain, that is more modular. Because when a class is required to implement a large interface that includes method that it will never use, it becomes very difficult to maintain and test. Many a times we have seen that whenever we face such problem, we have lot of unimplemented methods, and because some languages do not allow you to have unimplemented methods, we put unnecessary information or unnecessary comments or logs in those functions that this implementation of the class is not using. So that is not the correct way to write code, and that is something that we should avoid. Therefore, interfaces should be written after giving a lot of thought, and only that behavior should be encapsulated in an interface that is absolutely required for that interface to work or function. Anything other than that should not be sort of bundled in the same interface, because in future that can lead to unmaintainable or not good quality code. So how can a developer basically focus or keep ISP in mind? So again, we should just design interfaces by keeping very specific behaviors in mind. Whatever is the intended behavior, we should first think that behavior to a great extent, and only then we should create the interface that we want to expose to the outside world. If we follow this principle, then we can make sure that we do not add any unintended or unrelated methods in a interface, and we do not inadvertently create a large set of methods in a particular interface, which most of the classes that are implementing that interface will never use. The final principles in the S.O.L.I.D programming principles is the dependency inversion principle. This principle states that high-level modules should not depend on low-level modules, but both the modules should depend on abstraction. So many a times, or even today, what we see or how we picture code development is that there are low-level modules, then on top of it there are high-level modules, and then on top of it there are utility classes which use those modules, and then this is how the hierarchy goes. But that is not the correct way. This is a single direction hierarchy model where high-level modules depend on low-level modules, utility classes depend on high-level modules, and this actually makes code very difficult to maintain and very brittle, very difficult to change. So what dependency inversion principle says that high-level modules should not depend on low-level modules, rather both of them should depend on abstractions. The motivation behind DIP again is to promote development of code that is modular and easy to maintain. When high-level modules depend on low-level modules, it can become more difficult to maintain and test the system. And in addition, any changes to the low-level modules can have a ripple effect on the high-level modules. Because if there is a single direction hierarchy model, then any change that you do in the implementation of the low-level modules, if they are being directly used by high-level modules, then unavoidably you'll have to change the code of high-level modules. So this creates a ripple effect of changes in the entire code base. This creates every change a very invasive change, where you have to go at multiple places and fix the code base to accept new changes, and that is how it reduces the flexibility of the code base, because now any new change that you have to do, you have to make changes at multiple places. So to successfully implement dependency inversion principle, developers should use abstractions to decouple high-level and low-level modules. And in Java, at least, this can be easily achieved by using interfaces. And in other language also, there are constructs to achieve this. More or less in every language, that is an interface itself. So high-level modules should also implement an interface, and low-level modules should also implement an interface. And the interaction between high-level modules and low-level modules should be abstracted out. And it should only happen via these interfaces, and there should be no direct connection. So this will allow us to create more modular, testable, and extendable code. And again, keeping TDD in mind, each component of the system that is developed using dependency inversion principle can be independently tested, which makes it easier to identify and fix bugs. And also, if we follow dependency inversion principle, any change in the low level modules will not create any ripple effect, and the changes will be contained only to the low level module classes and will not spread out to high level classes. So in summary, again, this is a very powerful tool for developers to create maintainable, flexible and scalable software application. And this is again a very complex principle, or something that requires a lot of thought before you start writing code. But once you get into a habit of following this principle, it comes out very naturally, and also makes the benefit of using this principle very evident very quickly. So I think that is the end of all the principles that we have. By following these 5 principles, developers can create code that is a good quality production standard code, and also will result in a code base that is very robust, very friendly for new developers and very highly scalable. Also, it is important to note that these solid principles are just guidelines. They are not hard and fast rules. Obviously, there are no hard and fast rules in writing software, because anyone can write software as they wish. But again, as I said, that these are some time-tested principles of experienced software developers, which have been condensed into these 5 principles. So following these 5 principles, or at least following few of the principles in applications that you develop without any additional effort, results in a code base that is very good quality and very easy to maintain. So I think this is a good point for us to conclude. Solid principles are an essential tool of software development. As I said, that these are not hard and fast rules. We need not implement each of them in all the projects that we work on, but even if we have them in a back of our mind, then whenever we write new code, we'll know what is the better way of doing a particular thing, and this is how we can write good quality code. We might not stick to them very strictly, but at least in the back of our mind, we'll always be evaluating these principles, or evaluating our code against these principles, and see whether we are writing good or bad quality code. I think then that is it. I hope you like this podcast and got to learn something today. Be sure to listen to all our future podcasts. As of now, this is Shivam signing off.